that deal with those certain parts of the circle. They have special segments in a circle. The radius is a segment that goes from the center to the end of the circle, from the center to the circle, okay? That's radius. Diameter is a segment that goes all the way across the circle, and it has to go through the center, okay? We know this. We learned this in, like, 3rd grade. Congruent circles have the same radius. Now, we talked about similar figures in the last chapter, similar polygons, right? All circles are similar, okay? Well, the rules for two figures to be similar are that the angles have to be congruent and the sides have to be proportional. Well, there's no angles inside of a circle. There's only one. It's 360 degrees. And all circles are 360 degrees. So that means that satisfies that rule for similar, right? So the only thing you have is you don't have sides of a circle, but you can look at the radius, okay? And so if all the angles are always congruent in circles, the radius, you can say they're proportional to each other, all right? And so, but for it to be a congruent circle, the radius has to be the same. Okay, so if you ever see a question that says, are these congruent circles? All you have to do is check to see if the radius and the radii are the same. Okay? Chord is a segment with the endpoints on a circle. So diameter is a chord. Okay? It's just a special chord. Okay? But any chord that goes from one part of the circle to another part of the any segment that goes from one part of the circle to another part of the circle is a chord. And we need to talk about this because not in this section, but in tomorrow's section, we're going to have special properties related to chords specifically. Okay? So you need to know the difference between a chord, a radius, and a diameter. Okay? Those were special segments. These are special lines. Special lines related to circles. And this is one of the things that we're mainly going to be dealing with are tangent lines. These two are not segments, they are lines. Okay? A tangent line is a line that touches the circle at exactly one point. It intersects the circle in one point. So line K is a tangent line. A secant line is a line that intersects the circle in 2 points. It just goes through the circle. I mean, you either have a line, you have 3 different options. It can not touch the circle at all. In that case, it's just a line not related to the circle. It can touch the circle at one point, and in that case, it's a tangent line. Or it can go through the circle, and it'll intersect it at 2 points, and that's called a secant line. Okay, so these aren't segments, these are lines. We call this point the point of tangency. Okay? So if you ever see that term, that's what they're referring to, the point where that line touches the circle. The point of tangency. Okay, so let's check for understanding. You don't need to copy this down. Let's just check to make sure we understand the terminology, okay? So this problem gives you a figure and it says, tell whether the line or segment is best described as a chord, a secant, a tangent, a diameter, or a radius of the circle C. All right, sometimes it can be more than one. So when we're looking at, remember, when you're looking at these, this means segment over AD, and this means line over EG, okay? So segment AD, here's AD. Yes, it is a diameter, and it is also what? A chord. So it's a chord and a diameter. Okay? So now let's look at the next one. CD. So CD, that's just this. What is that?
Radius.
A radius. Why is it not a chord? It doesn't reach the other side. It has to go to both sides of the circle to be a chord. Okay? EG. That's line, right? Line EG. So that's this. So if I extended it, it would be a line. What is that? That's a tangent line because it only touches at one point. It's a tangent line. H B. That's segment HB. That's this right here from H to B, and that is just a chord. Now, what if I ask you that? It's a secant. If I said, what is line HB, then that means you would extend this that way, and that would be a secant line. Okay, everyone understand? So, it depends on whether it's a segment or a line. That'll determine whether it's just a chord or whether it's a secant line. Okay? Now, the next thing we're going to talk about is common tangents. These are, this middle one, we're going to talk about common tangents. Okay? Now, let's think about two circles. Two circles, they can intersect at 2 points. They can intersect at 1 point, or they can not intersect at all. And some of those cases have special names. If they intersect at 2 points, there's no special name for it. It's just overlapping circles. Okay? If they intersect at 1 point, they're called tangent circles, because that means those two circles touch at just 1 point. Okay? So they're called tangent circles. The line that goes through that 1 point is a tangent line. It's called a common tangent, okay? Because it's one tangent line that's common to both circles. Does that make sense? So this line right here is called a common tangent. If you want to. That line is called a common tangent, okay? Because it's one line that's tangent to both circles at the same time. Okay? That tangent line, that common tangent, can either be internal or external, depending on how the circles are placed. If that common tangent line is on the outside of the two circles, then it's called externally tangent. Okay? If that common tangent if that tangent line goes between the two circles, then that's an internal tangent line. External means outside, internal means inside. Okay, so you're not looking at the circles, you're not looking at how the circles relate to each other, you're looking at the placement of that line. Okay, so if this line is outside the circles, it's externally tangent. If it goes between the circles, it's internally tangent. That holds true even if the circles are not touching. Okay? If there's no point of intersection, you have two different cases. You can have two circles next to each other, as in this first case right here. There's no special name for that. Or you can have one circle inside of another circle. In that case, they're called concentric circles. Okay? If the circles are touching, they're not concentric, they're tangent circles. If the circles are not touching, then they're called concentric circles. Okay? God bless you. Now, when we're looking at two circles that don't intersect at all, we can still have a common tangent. We can still have a common tangent line. One line that's tangent to both circles. Okay? And as soon as I move this up, we'll see an example of that down here. Okay? But I'll let everyone finish copying this. Okay, so here are two different circumstances where the circles aren't intersecting, but they still have common tangents. Okay? So here we have circle C and circle D. This line right here, line K, is tangent to circle D at this point right here. Right? That same line is also tangent to circle C at that point right there. So because that line is tangent to both circles, it's a common tangent. Is it internally or externally tangent? Internally. That line goes between those two circles. So it's internally tangent. Does everyone see that? So if the tangent line goes between the two circles, whether those circles are touching or not, that's an internal tangent line. So this is internal. Both of them are. This line here, line J, it's common tangent because it's tangent to line C to circle C right there, and it's tangent to circle D right there. So it makes it a common tangent because it's tangent to both circles, and it goes between them, so it's internally tangent. Okay? And what about B? Are those internal or external tangents? External. They're common tangents. It's tangent there and there. So the same line is tangent to both circles, and it's on the outside of the circle, so they're externally tangent. Okay? Okay, externally tangent. All right, any questions? So if I give you two circles and I say draw the internal tangents, you should be able to draw those. Okay? Okay, properties of tangents. Here's the first one. Here's the first one. These are simple. The two properties we're going to learn today are simple. If a radius and a tangent intersect, then they are perpendicular. If a radius and a tangent line intersect, then they are perpendicular. Remember, radius goes from the center to the circle. So if they're perpendicular, what kind of angle do they form? A right angle. A 90-degree angle. So if a radius and a tangent line intersect, because they intersect right here, then that means they are perpendicular. That means it forms a 90-degree angle. Okay? That's what that property says. It works the other way too. It works backwards. If that segment and that line is perpendicular, if that segment and that line form a 90-degree angle, then that means this has to be the radius and this has to be tangent. If they form a 90-degree angle, then that line is the tangent line. Okay? So, when we look at our example problem right after that, that is what an example may look like. It'll give you a picture, and then it'll say, is this a tangent? Okay? Any idea on how we could prove that? Well, you can't look at it and tell. We know that in this problem, DE is a radius. We know that. Without question. It goes from the center to the circle. But we don't know if FE or EF is tangent. You cannot tell visually. You have to prove it mathematically. How can we do that? Pythagorean theorem. Very good. If you can prove that that's a right triangle, then that means it's perpendicular. That means it's a tangent. Okay? So, if it's a tangent line, this will be my right angle. So, if it's a tangent line, Pythagorean theorem will hold true. Okay? So, we have to check Pythagorean theorem. What's my hypotenuse? If that's a tangent line, what's my hypotenuse? 61. So, you have to say 11 squared plus 60 squared has to equal 61 squared. That is the question. If it does, then yes, it's a tangent. If it doesn't, then no, it's not a tangent. So you never want to depend on your visual judgment. You can only depend on your mathematical judgment. Okay, 11 squared plus 60 squared equals 3721, and 61 squared is 3721 also. So, yes. That means that's a right triangle. That means it forms a 90-degree angle, which means it's perpendicular, which means it is a tangent. Okay? Okay, let's look at this problem. Now, don't get scared off by a whole bunch of words. They give you, in this problem, when the word problem gives you a drawing to go with it, that's like Christmas. Okay? Because they're giving you the figure you need. The words are just the real life situation that goes along with that figure. So let's look at what this says. It says, you were standing at C, which means here's you, right here. So here's you. You're standing at point C, 8 feet from a grain silo. Y'all know what a grain silo is? People who live in the country know what a grain silo is. It's one of those big cylinder things that hold rice and grains and looks like a huge tin can. Okay, that's a grain silo. So this is like the view from above. All right? So you're standing 8 feet from it. All right? The distance from you to a point of tangency, so they're telling you that is a point of tangency. The distance from you to a point of tangency on the tank is 16 feet. So what is the radius? So this is what we have to find. So they're telling us that this is a point of tangency. If B is a point of tangency, then what does angle B have to be? 90 degrees, right? So that means that forms a right triangle. So in order for us to find R, what do? Pythagorean theorem. You have to use Pythagorean theorem. You have to use Pythagorean theorem to solve for R. So, this is one leg is R, my other leg is 16. What's my hypotenuse? 8 plus R plus 8. R plus 8. Okay, so you're going to say R squared plus 16 squared equals R plus 8 quantity squared. Yes, go ahead, do that now. Okay, so yes, you have to do it. R squared plus 16 squared equals R plus 8 squared. No, you can't ever assume that this is the same as that. There's no theorem that says that's true.
Plus 8 squared? Or is R plus 8?
R plus 8 squared. Yes. R squared plus 16 squared equals R plus, you have to square the whole thing. So you have to put it in parentheses. And I better not see anybody say that this is R squared plus 64. I better not walk around and see anybody say that this is R squared plus 64. What do you have to do with this?
You have to multiply twice.
You have to multiply times itself.
Yeah.
You have to expand it. Okay, so you should have gotten R equals 12. Because you have R squared plus 256 equals R squared plus 16R plus 64. When you expand R plus 8, remember R plus 8 is squared is R plus 8 times R plus 8. Okay? And that distributes to equal that. Okay? And so my R squareds cancel. So I just have 256 equals 16R plus 64. Once you subtract 64 from both sides, you get 16R equals 192. Divide by 16, and R equals 12. Okay? R equals 12. Okay. Any questions? So a lot of these problems, you'll be using Pythagorean theorem if you need to find a missing piece of that right triangle. Okay, so you'll have to, if they tell you that line is tangent, then that means it forms a right angle. All right? The second property, property number 2. intersecting segments are tangent to the same circle, then they are congruent. If two intersecting segments are tangent to the same circle, then they are congruent. And let me assign these values. So let's say this is circle C. This is point D. So, segment DA and BA, they intersect at point A. Those two segments are tangent to the same circle. They're both tangent to circle C. Okay? If they're both tangent to circle C, then that means they are congruent. So DA is congruent to BA. So segment DA is congruent to segment BA. So as long as you know that they're tangent. Now there's two different ways they could either tell you that they're tangent, as in the next example. The given information says this segment is tangent to the circle. Okay? Or they could show you that they're tangent by putting the right angle symbols right there. That means they are tangent. Okay? Okay, so in this example, this is the given information on the left. They tell us that AB is tangent to circle C at B. So this is our point of tangency. And AD is tangent to circle C at D. Okay, so they're telling us that these two are tangent lines. So that means that that is congruent to that. So if we have to solve for x, what does our equation look like? X squared plus 2 equals 11. And then you just solve for x. So we subtract 2 from both sides, so x squared equals 9. Take the square root, so x equals plus or minus 3. Now, anytime you have to take the square root to solve any of these, or if you factor, if you have to use, say, the AC method to factor it and solve it, if you get more than one answer, you need to go back and look at your picture, look at your diagram, and see if both of those can work. Because remember, a distance can't be negative. So positive 3 and negative 3. When I go back to my diagram, this is where x is. It's okay for it to be positive or negative 3 there. But for example, if this diagram, if I added something to the diagram and I told you that the radius, let's say they said the radius was x. Now, that would be unnecessary information to actually find x. But if they told us that this radius was also x, then can that be negative 3? No. So if that piece of information was on there, then my answer would only be positive 3. Does that make sense? So you have to go back and look at the diagram and make sure, especially if you get if your answer is one positive and one negative, you have to go back and look and make sure that that negative is legal. Okay? In this case it is. So x equals positive 3 and x equals negative 3. Okay? Any questions? Okay, the next problem is what a problem from the worksheet that I'm going to give you looks like. Now, I want you to try this one. But this is what the directions say. They say solve for x. Assume that lines which appear to be tangent are tangent. So they're not putting the 90-degree angles, and they're not specifically saying this line is tangent to this circle. They're just saying if it looks like it's tangent, assume that it is. Okay? So, which means that this line and this line are tangent lines, right? Which means that those have to be what? Equal. Okay? 23.9, is that relevant? No, that's unnecessary information. They drew other lines in this diagram that doesn't matter, that are irrelevant. Okay? 23.9, that's irrelevant. We don't need the radius to find x. Okay? Because all we're doing is solving for x. Okay? So we know that that has to be congruent to that, so solve that. Okay, so 5x plus 12 has to equal what? Negative 2 plus 7x. So now we just solve for x. Subtract 5x from both sides. Add 2. You get 14 equals 2x. Divide by 2 and x equals 7. Now, that is all this problem asked of us. However, it could ask for more. For example, if I did this. If I did that, and then I said, then I'll find y. Let's say that again.
Find what -2 plus 7 equals
Yes.
the difference.
Yeah. Good. Anybody else have it? That's right.
No, you can.
Because nobody heard you. So what would you do? What would you do?
23.9 over y and then y over 23.
No, that's not a double right triangle. You can't.
Oh, never mind.
No. Pythagorean theorem. If this is tangent, that forms a right angle, correct? And here is my right triangle. They gave us this. It's 23.9. This is what we're trying to find. How do we find out what this is? Plug in x. You already found x, so plug in x. Y'all go find y. Okay, so this one is 23.9. This is -2 plus 7 times 7, which is 47. Okay, so we have 23.9 squared plus 47 squared equals y squared. So 571.21 plus 2209 equals y squared. So y squared equals 2780.21. Take the square root of both sides. And y rounded off to the nearest tenth is 52.7. Okay. Now, find z. Oh. It's 23.9. Z is another radius. See, that's why y'all shouldn't panic when I put something up. Sometimes it's really simple.
It's crazy.
23.9. Okay. Radius is the same no matter where I draw it. Radius is the same distance all over the circle. Okay. That's why I put that, so you can recognize that. Okay, any questions so far? Okay, the next two problems are like problems on your worksheet. We've learned everything we need. We have all the tools in the toolbox to work these problems. How do we find perimeter?
Adding everything together.
Adding up all the sides, right? I don't care how many sides it has. If it's a polygon, it didn't matter if it's 10 sides, you add up the distance of all the sides, right? So these next figures, you have to find the perimeter of the polygon. Okay, we're not doing negativity in this classroom.
We don't play that.
We don't play that game. Okay? Only positivity.
Obviously.
Now, no. Do you see any radii in here?
No.
So we can't see the right angle. So we're not using Pythagorean theorem to find any of these. They gave us everything we need to find the lengths of all sides. Remember our theorem that says if two intersecting segments are tangent to the same circle, then they're congruent, correct? Okay. So, let me help get you, well, look at it. Uh-huh. No, you can't say half. There is no theorem that says the tangent line is a midpoint. No. You're not, the only thing you can cut in half is the diameter to get the radius.
So 9 over 13.6 equals.
No. Come on, people.
And 17.4 minus 9, and then you have 9.
No, 17.4 is not related to 9 at all.
So,
Oh, yes, it is. Yes, it is. Because if this is 9, what's this? Okay, that should unlock everything else for you.
so 4.6 minutes?
Right here.
That's
Okay, now y'all can do it. Go. What? What?
17.4 minus nothing.
Is
8.4.
is this. And whatever this is, that's about it. Okay, y'all work this.
This is too easy.
If the whole thing's 17.4 and this piece is 9, how do I find this piece? Subtract it. What's 17.4 minus 9?
44.
What is 17.4 minus 9?
8.4.
So if that's 8.4, what's this?
8.4.
Now, if this, and lastly, if this is 4.6, what's this? Now you add up all the sides.
Get 44.
Now y'all do the second one. Okay, so if this whole thing's 14.3 and this is 8, 14.3 minus 8 is 6.3. And if that's 6.3, that's 6.3, right? Okay. Now, if this is 8, what's that?
8.
8. So this whole thing's 14.8 and this is 8. What's that? 6.8. So if this is 6.8, what's this?
6.8.
Now, when you add them all together, you will get P equals, oh, I didn't do the, oh, whoops. I forgot. If this is 11, that's 11. Okay? So now when you add them all up, you get P equals 64.2. Any questions? On the first part of your worksheet,
It's easy.
I need to, here's what your worksheet looks like. Now, the first section says, determine whether AB is tangent to the circle. So you have to prove Pythagorean theorem for those. Okay? So you have to prove Pythagorean theorem. If AB is tangent, then your right angle will be here. So you check to see if 12 squared plus 17 squared equals 20 squared. Okay? But you need to be careful with things like number 3. Okay? AB is what we're questioning on whether that's tangent. So here's my right angle. So we need this side. What's this side? 9. Because it's a radius. They give you the radius right there. So the radius is the same all over the circle. Okay? For number 2, if AB is tangent, it forms a right angle with the radius, correct? This is my radius. Right? Everybody? Eyes up here, right? Okay. If it's perpendicular, if it forms a right angle with the radius, then it stands to reason that it still forms a right angle with the whole diameter. Okay? So it's still one big right triangle.